For those of you familiar with polar coordinates, we're looking at r plus theta, very simply, but it's a really pretty object, I think.
It looks like a pinwheel.
Exactly. Would probably behave like such in the wind, too. Let me change the colors a little bit. See, it's real easy to get a different effect in the colors.
But it's still a pinwheel.
Right.
With many, many blades.
Right. This particular set of colors itself seems to show some three-dimensional effect just because of the shading. Kind of look like tubes. But it's still just 256 different colors. Well, some of the colors are the same, actually. We have some blacks in there that are several of the 256 colors are black. Well, let me take it a step further and take that object and add some special effects to it.
Oh, my.
So this should look just like the thing you saw, except it's a little bit smaller, and there's a lot more of them.
There are a lot of them. Looks like about 16 by 16 or so.
Yeah. Now, if I could find the mouse. There it is. It's a problem. I actually have two video boards in here, and sometimes the mouse wanders down into or the cursor wanders down into the other video board, so I have trouble seeing it. Okay, this is how I add special effects to it. For instance, the size of the pinwheel is affected by these two parameters. I can stretch it in either direction or squeeze it in either direction. And this parameter changes the...
Now, these pictures are actually showing that.
This yeah, I tried to do a...
and this is squeezed.
I tried to do a before and after on these. So, for instance, in this case, you take a small square around the center and repeat it over and over.
That's what we just saw.
Right.
All
so
these
you saw
postage stamps.
multiple copies of the same thing. And all of these effects have a parameter related to them. For instance, for this tiling option, the postage stamp, as you called it, this number reflects the size of the square you're using.
Okay, I think I understand now when you were talking about it being like a music synthesizer, because this is the same thing they do in the early days of music synthesis. You hook together many modules and process the signal, and it looks like you can hook together...
Yeah, they call that chaining, I think.
Chaining the modules. So you can chain your functions or your modules
Right,
here.
so, if I want to take one particular effect and then add another effect off that...
Mental activity of video synthesis? Then?
That's right. Just put the pieces together and you get some new video. Okay, well, next we can look at this same function with some added special effects. We close that.
Okay, so this is like running it through another module of synthesis?
Several more, as a matter of fact. This is mapping it onto a sphere, so you get that spherical look. I've added some random noise to it, so there's a sort of a texture to it, and...
Oh, yes, I can just barely see the texture.
Well, it might be hard to see on TV. It's easier to see on a monitor. Things look a little fuzzy anyway. And also I've done some scaling on it, which mathematically is flattening out the equation. In the case of the artwork, it tends to spread things out a little bit so that the props of the pinwheel look a little bit wider.
Okay, and do we have more?
Well, I wanted to show you a little trick I developed. Somewhere along the line I decided that what I wanted to see was two functions at the same time. One is never enough. And one way you can do that is by just opening a second window, of course. And this is how fast it fills a window. That is our old friend z equals x for a function.
And that's amazing. Are you having to do twice as much computing now to do two of these video synthesis artworks at once?
Well, no. Actually, this kind of comes for free. These windows are just filled. That's where the real computing takes place, as it fills the window with the object. But the animation you get, again, is done by the color palette trick to move the colors around.
It's rotating the indexes.
Right, the set of colors.
Lookup table, yes.
Exactly.
Okay.
But I wanted to show you anyway what a window looked like, and that you could have more than one and play with them like regular Macintosh windows. That's a bit of a cheat, though, for getting two things at once. What I really had in mind was something that I call multiplexing. And let me show you an example of it. I think I chose the word multiplexing just from my data communication background.
Yes, you take one signal and then another and alternate them?
Right.
Yeah. One
getting many into one, or demultiplexing, getting many out of one.
Now I only see one signal here.
You only see one signal, but there's actually two functions going on. If you can see the spokes of the wheel.
Yes, I can see the spokes.
And also the circles that are expanding from the center.
Yes, expanding concentric circles.
Okay, so those are the two functions that are involved. One is the square root of x squared plus y squared, which you saw before. And the other one is arctan of y over x, which is just the spinning spokes, or the spinning wheel. So these, in effect, you're looking at two functions at the same time. The screen is filled 50% with one and 50% with the other. The first way I thought of doing this was to just regularly stop at each pixel and either use one function or the other, a pixel being a picture element, the smallest units on the screen, what I'm really painting with. So it was either one function or the other very regularly. Like the odd ones would be one function, and the even numbered pixels.
You're saying
would
every
be
other
the other function.
every other dot on the screen would be either one picture or another,
right.
Like a double exposure.
Right, just like a double exposure. That's very much what it would look like.
Okay.
Very quickly, I decided there were other ways to do 50% one function and 50% the other, and it occurred to me that I could use a flip of the coin at each decision point to decide whether to pick one function or the other.
So this is really random.
This is an example. I call it stochastic multiplexing, just to be fancy, or random multiplexing. It has an effect of giving a nice texture to the
yes,
to
it
the
looks
object.
like a frosted glass window.
Yeah, I think so. Let me.
I've never heard of this stochastic multiplexing before. It's random multiplexing. It's a new idea.
Right, you're sort of getting two things for the price of one. I guess in the case of the brain looking at an artwork, you fill in the missing details, but you could just as well not fill in missing details, have everything there. Twice as long. Let's look at some other versions of this. I can pick other palettes that give it a completely different look. Let me try something simple.
Kind of an aquamarine look there.
No, I call that the water palette. I based it on a swimming pool, I think I saw once. There's simple palette going from white to blue to black. You could probably see better what functions are. The expanding circles and the
it looks entirely
wheel.
different.
Right. Now, some people like it to spin the other direction, and I can do that. There's a control for saying which direction things are moving.
Yes.
And let me go back to this original palette, because the effect gets even better. So now it's spinning. I guess the wheels are spinning clockwise and things are retreating. Now, actually, I like the expanding view of things better, where it looks, I don't know, just more positive to have things expanding rather than shrinking. But you can have both at the same time. I call this sinusoidal animation. Instead of just simply rotating the set of colors, I'm rapidly spinning them one direction, then slowing down and stopping and spinning them the other direction.
Yes, this reminds me of a washing machine.
Well, yeah, I think this could...
something hanging and twisting.
I think for those people who like to sit at the laundromat and watch their laundry go around, I think this could be a cheap alternative. If it doesn't make them seasick. Let me show you another function here.
Okay.
Something that I just picked as being more artistic. This again involves multiplexing. In this case, this is the regular multiplexing I spoke of earlier, whereby I'm just picking every other pixel as one function or the other. The two functions I use here happen to be almost the same function.
And which are they? Can you outline them?
Well, one has petals going, look at the flower there. There are a set of petals going in clockwise spirals and another set of petals going counterclockwise.
Oh, so these are two spirals that go different directions,
yeah.
but
I can
together.
Right, I can stop the motion briefly.
I see, yes.
So you can see, those are the two functions. One is a clockwise spiral and the other is a counterclockwise spiral. They're really the same function except mirror images of each other. And I put them on the screen at the same time.
And how long does it take to compute a function or a set of two functions like this?
Well, you asked me at the right time. This particular function is the one that I believe takes the longest to compute. It is rather intensive in trigonometry. It's based on a Rose function, so-called, but it's got an added effect whereby, based on the distance from the center, you rotate the object one direction. So there's a lot of trigonometry going on. This one takes a few minutes to fill a
But
screen
generally
with.
it takes about a minute or so.
A minute or two, yeah.
Okay, well, you know, I have an idea. Hey, Mr. Bill, that's our director, Bill Weigel. Do you think you could do a max headroom effect with us? Do you have a good background that we could use for that?
Let's try this one.
Thank you very much for being with us this week, Hud. And I hope everybody will watch for the next episode of High Tech Heroes. We have planned another guest by the name of Simon Field, a technologist from the area, who has begun to study electric fish. He found that there were a number of small fish that you could have in your own aquarium or fish bowl, and they emit electrical signals, strong enough to shock you, actually. And these fish use these signals to communicate, and also, at least he believes that they use them to communicate and also to locate with radar. And I guess it's analogous to what dolphins do in echolocation. So I think that's very interesting, and that should be a very interesting show. So be sure to watch for the next episode of High Tech Heroes, when we'll show you electric fish. And thanks again for being here on the show,
pleasure.
Mr. Nordin. And I really like this. I'd like to have one myself.
Let me show you another function.
Sure, I'd love to. I mean,
I have plenty of these things.
I can play with this all day.
Thank you for joining us this week on Foothill Focus for the pilot episode of High Tech Heroes. Be sure to tune in again next week when we will be bringing you more entertaining information about people and activities at Foothill College. And now, this is your announcer, R. Conrad Griffin, wishing you the best of luck and a pleasant spring.